Good evening. So today what we're going to do is we're going to do section 1.3, right? And then 1.3 is deduction versus induction. Now, as far as arguments go, these two distinctions, so let me turn this a little bit. So these two words, for the most part, as far as our course is concerned, is the only two species of arguments that there are available. So like this distinction goes all the way down like plants versus animals, right? Of course, there are the majority of arguments, the majority of living things on this planet are probably mostly animals, right? But plants also are living things as well, right? So deduction versus induction. Now, what does deduction refer to? You've been using these two ways of reasoning about the world for most of your life, even if you've never attached these specific terms to that type of reasoning. Now, deduction versus induction is largely differentiated by the relationship and the form or shape of an argument and how the premises entail the conclusion in an inference. So there's a difference of relationship between the premises and conclusions in deduction and versus how that relationship differs in induction, right? So there's different ways. So now most of the course in terms of formal logic is concerned with deduction. Now, induction is with us for 2/3 of the course, so it's still important, but it's important to recognize that most of the reasoning outside this class and say your science labs that you take in the core or your methods courses if you're a social science major, a lot of that will be induction, right? So it's still an important concept to know and it tracks a lot of what you're doing elsewhere. Now, let's take a look and define deduction. So deduction is reasoning by necessity. Now, to get clear in a moment what I mean, right? But let me give you an example, right? In terms of a deductive argument. So a standard deductive argument might go like this. Premise 1, all dogs are mammals, right? Premise 2, Snowball is a dog. Right now, we have this very universal premise, and we start narrowing in. And we have Snowball is a dog. So if all dogs are mammals and Snowball is a dog, then by necessity, the only conclusion that follows in this specific form is what? Pause the video. Did you come up with Snowball is a mammal? And it doesn't really matter because we can actually have an argument with the same form with true premises necessarily entailing a true conclusion in a different way, right? So let's take a look at if we did this just slightly differently. So we're going to actually preserve this form of argument, but we're going to change the content of the form, right? So we're going to put different stuff inside this form and still have a deductively valid argument structure that has a sort of implies the conclusion necessarily from its form. So same form, different strategy, right? So premise 1, all men are mortal beings, right? Mortal means that you can die, right? All men are mortal beings, right? 2, Socrates is a man. Now, like all dogs are mammals and Snowball is a dog, this middle term still stays the same, right? We have an all these things are this way kind of statement right here, right? Which we will call a universal affirmative a little bit later, right? But for now, it's all this stuff are this stuff kind of statement. And then we narrow in and we say this specific thing, Socrates is a man. So likewise, pause the video. What's the conclusion here? Did you get Socrates is a mortal being? It works the same way. So in deduction, we have form, right? The forms that reasoning can take place with statements, right? Now there's different forms and we will commit them to memory as we go forward. But for right now, that's what it means to reason by necessity. And it's so necessary that if these are true, right, this conclusion will automatically be true because of this form. That's why there are different argumentative forms versus invalid forms. But we'll pay attention to that in 1.4, right? So reasoning by necessity. Now, what makes induction different than deduction is that the arguments for, right, induction are, instead of reasoning by necessity, right? Let's do a little window here. It's reasoning by probability. So I'm going to give you a very painful example. Not painful, just, you know, because I'm from the north and, right, today is like 95, but it feels 100 out, right, because of the humidity, right? So let's go and give you an inductive argument. Premise 1. For the past week in Baton Rouge, the temperature has been over 90 degrees Fahrenheit, right? Or somewhere around 30 plus C if you're an international student, right? For the past week, the temperature has been over 90. Conclusion. Therefore, probably tomorrow it will be 90 degrees plus Fahrenheit or 30 degrees Celsius, right? So premise 1, for the past week in BR, the temperature has been over 90 degrees. Hot, right? It's freaking hot in Louisiana. Now, is this a good argument? Is it possible that a cold front might come dip down from the north and might put us like at 82 degrees 1 or 2 days and then it will return to normal? Yes, that's absolutely probable. It's an improbable event, but it might happen. And our level of certainty, and now there's no guarantee of this form, right? There's some other norms that govern inductive arguments, and we'll pay attention to both strength and cogency in the next chapter in 1.4. But for right now, the relationship between this premise that it's been hot in the past, it's been these hot temperatures, so it will continue in the future, right? That's probable, that's likely, right? Or it might be the case. Now, will the future absolutely conform to the past? There are possibly some deviations from those trends, but the weather in the summer is characterized by this behavior. So we don't throw out reasoning by probability simply because there might be outlier or improbable events that will be on the periphery, but for the most part, right? So if I were to line up all the students, all 7,000 students that go to Southern University, right? And say that I was an academic advisor and I had to code whether or not the students who I give academic advice to are both male or female, right? Now, if you take a look at collegefactual.com, the gender distribution for us is 35% male, 65% female. So you can't, so for about 6 or 7 out of every 10 students will more than likely be female. So you can't universally just say that there are no men on campus, but there are remarkably fewer men than women. So I could code 60% of the time I would be right if I just coded female versus male, but I can't do that all the time. And we deal with phenomena all the time where probability reasoning actually is what's going on. And of course, that's the difference between deduction and induction, right? Now, the book gives you a confusing definition. Now, I'm going to front load this lecture and give you the reason why. So they front load both strength and cogency in the definition for induction, and they give you, they sort of hint at validity and soundness in the definition. And they do that to sort of prime you for the next section. But this is ultimately what deduction versus induction actually is. Now let's go to the text and pay attention to what Hurley and Watson, I believe, is the new author that's alive, right? So let's go pay attention to what they're doing. So I'm going to transfer to the text right now. So share my screen. All right, go here. And then I knew how to get rid of that. Maybe these pages go away. Anyway, right? So this is where we are. And let me try to make this bigger, right? And I'll go in here. So let's pay attention to this, right? So they define a deductive argument as an argument incorporating the claim that it's impossible for the conclusion to be false given that the premises are true. That's another way of saying that if I have true premises in a good deductive form, my conclusion will always follow as true, right? So they're incorporating validity into this definition here. Inductive argument incorporates the claim that it's improbable the conclusion be false given the premises are true. But it's not 100% guarantee, right? Because again, we could take a look at, you know, what I just did for the inductive example. So for the past week in Baton Rouge, the temperature has been 90 degrees Fahrenheit or 30 degrees plus centigrade, right? So therefore, probably tomorrow it will be above 90 degrees Fahrenheit or 30 degrees centigrade. So now, is it possible tomorrow's going to be 88, not above 90? Absolutely. That's a little bit more likely than it dipping down to 70 degrees, right? But we know that this is, you know, Louisiana is as far south in the continental United States on the East Coast that you can go before you hit ocean, right? Well, actually, that's not true. Florida is a little bit further south on the East Coast, but we're in the Gulf, right? Some birds from Canada just go like, yeah, this is good enough, right? So they plop down here. And it's warm here, right, in the winter. So they fly south for the winter. We can actually see the tension between reasoning by necessity and reasoning by probability. So pay attention to the second one. This argument right here, right? Now remember, it doesn't really matter what order the premises come in, as long as we have things that are relative. So all dogs are mammals. That argument is very much similar to this one. All members of the mongoose family are carnivores. The meerkat is a member of the mongoose family, therefore, right? And they've built into this, it necessarily follows that the meerkat is a carnivore. Now that necessarily follows is to illustrate that this is reasoning by necessity. We wouldn't, even if we didn't have it necessarily follows, we could tell by the argumentative form that I showed you that this is the same form, right? And formal logic gives us the appropriate shape of reasoning, right, versus other bad shapes. So the content does not matter. This is a valid argument form, right? Content will matter in the next section. So take a look here. The meerkat is closely related to the suricate. So the meerkat and the suricate, I don't know which one, but you remember the king in Madagascar, the cartoon when you were growing up? One of them is either meerkat or suricate, little small things. I can show you a picture here. But let's say you've never seen one, you don't know what they are, but you know that they are morphologically similar. They look to have a similar evolutionary history. Maybe they have a close they're close in genetic makeup, right? So all these things. So let's say that for these reasons, we say premise one, the meerkat's closely related to the suricat, right? Now, you don't necessarily know what a meerkat is, but if it's closely related to it, the second premise, the suricat thrives on beetle larvae, and you've never seen a meerkat eat, you might say, therefore, probably the meerkat might eat the same thing as the suricat, right? In which case it's beetle larvae. So that is an inductive argument. And if these two statements are true, then it makes the conclusion improbable to be false, but not impossible to be false. And that's the difference between deduction and induction. Induction is a little bit looser, and it doesn't have adherence to strict form as the deductive arguments go, right? Now, how do you tell the difference? Just if you had two arguments standing side by side, that connection between the premises and the conclusions is one of probability for the inductive. So sometimes there are inductive indicators, as our book calls it, right? Improbable, plausible, implausible, likely, unlikely, reasonable to conclude, right? And then additional deductive indicators might be certainly, absolutely, and definitely, right? Because the words certainly, absolutely, and definitely imply a level of necessity that the conclusion is necessitated by the premises, right? So, and all the inductive indicator words are ones of probability. So if you see these in a passage, you know, these can help you. But just like the premise and conclusion indicators, remember, they're more like guidelines, really, right? So again, I'm referencing the pirate code from Pirates of the Caribbean. All right, I don't know why I have a football, so I just put that away. Sometimes it helps me think. All right, now, again, you don't need to know those things. So the next thing to discuss in this chapter will be the deductive argument forms versus the inductive forms. So our book gives a taxonomy of some likely gives a taxonomy that you're going to have to use in a future homework to say this is this particular deductive form, right? And it introduces you to the notion of form very early on in the first chapter, because remember, a great deal of this course is going to be about deduction and all those different argumentative forms. All right, so I'm going to transition back. I'm going to basically start now explicating the list of deductive argument forms that starts on page 35, and that will go to page 36, and then inductive forms starts on page number, let me get it for you. That'll start on page 37 and then go to 38. Yeah, okay, so and then I'll take about 15 minutes on that, and then I'll end this video, and then I'll upload another one about homework practices using this list, right? So your homework will be problem set Roman numeral 1 at the end of 1.3 in the bluish green section at the back of the section number, right? Okay, go back to here, click the unshare button. Okay, we're back to the video here. And then I'm going to erase this, right? And then I'm just going to create a list. All right. Now let me bring up my textbook. Okay, so let's go back to page 35 at the very bottom there. So deductive arguments, and even as the book says, have a distinctive character or form that indicates the premises are supposed to provide absolute support for the conclusion. The word absolute support is just that level of necessity that we've been talking about. So the first one, right? Deductive argumentative forms. So my word here is arg, which is short for argument, right? So argument based on mathematics, right? So arguments based on mathematics are either computation or measurement. They can be either computation, right? They can be formulas, computations, or measurement, right? But in general, right, if I were to give you a problem like 2n plus 3 equals 7, right? Or I were to give you a problem 2n plus 2 equals 1, you're gonna do this the same way, right? You're gonna reason deductively about it because you're gonna start with a very general principle, right? And that general principle will be called the balance of equations. So for the solving of any particular algebraic equation of this particular form, I'm going to take 3 from both sides. So I'll do 2n plus 3 minus 3 on this side of the equal sign, and I'll go 7.7 minus 3, right? And once I compute that, I'll get 2n equals 4. And then I'm going to divide both sides by 2, and n equals 2. Now, n equals 2 in this particular equation, and it's not ever going to be anything else. It's always necessarily going to be, and if I wanted to check my reasoning, right, deductively, I can plug this back in and I can check myself, right? And I can say 2 times 2 is 4 plus 3, that equals 7, right? And n could only be 2. Now, you're going to say to me, well, I'm not really that great at math. Well, you might not be that great at math, but in order to do mathematics, you need to think deductively, just like I did. And I could do that with any equation of that form, right? And it doesn't stop there because arguments based on mathematics can also be measurement, right? So if I gave you 3 people, right? My mom is 5'1", I'm 5'5" and 3/4", but I vainly like to say that I'm 5'6", and then LeBron James, right? So if you said, if I said to you, Dr. Hackett is taller than Sharon Hackett, my mom, and I gave you the premise, LeBron James is taller than Dr. Hackett, therefore it follows that LeBron James will always be taller than Sharon Hackett. And that's always going to be true, regardless, right? Because I don't know how, if he's 6'5", 6'7", 6'8", he's somewhere up there, right? But those measurements are never going to change, right? So measurement also entails a level of necessity, right? The next is argument from definition. Arguments from definition are always 2 lines, right? So they, you know, so our book example is this, like Claudia, premise 1, is mendacious. Mendacious means being deceitful, right? Or lying. So Claudia is prone to lying. Therefore, Claudia lies. Now, the fact that she lies is basically that mendacious is defined here as applying to Claudia. So if this one is true, this is true by necessity because you're just saying what the word means, right? We'll see in the homework, there's a really great example of an example. So we'll see some more, but there are only going to be 2 lines. There's not going to be 3 lines for arguments from definition, right? And they are strictly like, this is this definition, right? And you see a lot of reasoning by definitions inside our logic class to begin with. Okay, so now the next one is hypothetical syllogism. And the book throws anything with an if-then is an example of hypothetical syllogism. But for right now, the way I'm teaching this course is I'm basically going to give you all the forms of if-then statements, right? So hypothetical syllogism is technically if A, then B, if B, then C. Therefore, and since this same statement, this letter symbolizes the whole statement, is in the consequent position and B is in another line is on the antecedent position, then you can necessarily conclude if A then C. That's technically hypothetical syllogism. There's two other conditional argumentative forms that correspond, right? So there's also, and I'm just lengthening your list a little bit, introducing it to you now. Modus ponens, which is not on this list, but I'm requiring you to think this way right now. Modus ponens is if A, then B, A, therefore B. So here's the example. If Dr. H is in Baton Rouge, BR, then Dr. H is in Louisiana, state abbreviation LA, right? So that's this one right here. Now think of if-then statements as a conceptual truth, right? If anyone's in Baton Rouge, it would be true they'd be in Louisiana, right? I am actually on campus in BR, right? So Dr. H is in BR. Therefore what? Yes, exactly. If I'm in BR, then it necessarily means that I am in. Dr. H is in Louisiana. I like to use geography because it's really intuitive, right? So that's modus ponens, and it only can be this way. You can't flip B for an A, otherwise it's fallacy, right? Check the invalid cousins chart in the Moodle. So that's that one. Then there's modus tollens, right? So modus tollens. Modus tollens is if A, then B, not B, therefore not A. So here's the example. If Dr. H is in Toronto, as in Toronto, Ontario, Canada, then, you guessed it, Dr. H is in Canada. That makes sense. And for anyone that's in Toronto, they're necessarily in Canada, right? Now, in modus tollens, we take the negation of the consequent from the first line, right? So we say, it's not the case that Dr. H is in Canada. Therefore, if I'm not in Canada, where can't be? Correct, right? I can't, it's not the case. Therefore, like little three triangles means therefore, it's not the case that Dr. H is in Toronto. So you'll need to know these three, and I'm just going to introduce them now, right? So I'm adding a little bit of extra to our book, right? So let me, sorry, I know I keep deleting. Okay. Categorical syllogism, we didn't really go over. Categorical syllogism is what you've been looking at in terms of all men are mortal, right? So our book defines a categorical syllogism as any two-premise conclusion format in which the first word is all, no, or some. We'll explain what that means later. And then the last one is called disjunctive syllogism. Disjunctive syllogism is always an either or. So either Dr. Hackett is leaving at 4 p.m. today, or he is not leaving at 4 p.m. today. Technically, I'm leaving in 20 minutes. So I as far as I know, so, right? So what happens in disjunctive syllogism is you have an either or, right? So you have either A or B, and they have to be mutually exclusive, right? And then it doesn't really matter which one. You say not A, therefore B. Or what you could do is you could say not B, therefore A. But you basically negate the one that's false and affirm the one that's true. Right? It doesn't really matter how you go. It's just you have to negate the false one on the second line. And that's disjunctive syllogism. And there you have it. Those are the deductive argument forms, right? I'm running out of water here. Woohoo! Got spray. Might as well use it. So that might be the maybe water's better. Now, with inductive argument forms, right, we have some things going on. So for induction, right, we have prediction. A prediction is an argument that the past establishes a pattern that the future will conform to. So my example to you in the initial about the weather was a form of prediction, right? So if we say, for example, someone might argue that because certain weather conditions have been observed to develop over a certain region of central Missouri, a storm will occur there in 6 hours. Or again, one might argue that because certain fluctuations occurred in the prime interest rate on Friday, the value of the dollar will decrease at the start of the next weekend, right? So the point is, some things we can predict with some regularity, even if we don't really know, or we're not in absolutely any position to know the future, right? Argument from analogy. So if you use analogies, right, so remember analogies on the ACT or SAT, right? So a pitcher of water, so water is to pitcher as milk is to gallon container, right? They're very similar. So basically, our book's example is kind of lame, but we'll use it anyway, right? So here's the analogy. Angela's Porsche is a great handling car. Therefore, if Christina buys one, it'll also be a great handling car. So you're basically, but this is inductive because the property between the two things that you're comparing might not necessarily, it might not be so similar that you can actually make that judgment, but we do use arguments from analogy. Of all the inductive arguments, argument from analogy is the weakest form of inductive argument. So always be wary of anyone who just has an argument from analogy, but doesn't have any other arguments to assist the advancement of whatever they're claiming. Generalization. Generalization is a really great piece of reasoning, right? So generalization is, if I have a representative sample of a population of stuff, I could make generalizations about the whole. The most mundane example might be, like, say I have a bushel of apples, right? And I keep pulling out an apple and be like, this is a red Macintosh apple. This is a red Macintosh apple, right? And they come from the apple orchard. So I go through 100 of the apples. They all tend to be red Macintosh apples. And I reach my hand for the bottom. I can't see, it's really dark. But I could say, like, you know, I got this sample and then I see a truck of apples, right? And I know on the order form, it says, oh, you know, red Macintosh delivery day. Then I generalize, from this sample, I'm going to say that those bushels in the truck are red Macintoshes without even really like looking at them. And sometimes that's really good. This is how we, you know, people leave the voting poll, and then people like record how they voted, right? And then so that polling comes in as data, and maybe they work for CNN, right? And they say, based on the trends of all the people that we have on the ground collecting data, we're going to generalize that Biden won this particular county in the last presidential election, for instance, right? So statistical generalization we use a lot of. Generalization can also be a form of fallacious thinking. We'll cover that a little bit later. Argument from authority, right? So arguments from authority rely on the human expertise that someone is a qualified authority to be a source of evidence, right? So most likely you're thinking court trials, right? So if there is a forensic scientist and that forensic scientist can say things about why the evidence leads to the conclusion that Mr. Smith is the murderer, right? then we listen to that scientific evidence presented by that expert as a source of evidence to inductively infer that indeed Mr. Smith is the murderer, right? Arguments based on signs. Don't overthink arguments based on signs. Quite literally, right? Signs are put up like the sign right at our campus might say, some university was founded in 1880. Now, could a human being have made the wrong year? Like, could we have, chances are, yeah, human beings make signs with information. But chances are, if you're driving and you see a swivelly sign, right, you're going to think, oh, the road is curvy ahead. I better slow down. And if you don't obey the sign, chances are you can go off the road, right? So arguments based on signs. They're put up by human beings. They could contain false things. But is it probable or improbable? That's a question for each individual sign. And then causal inference being the last one. Causal inference is trying to infer that some particular thing or person caused Y, right? So it's always a claim about cause and effect. And actually, causal inference is the goal of all scientific reasoning. We'll have a class discussion on that later. But these are the inductive, and in each different one, they're not precise, but they have the language of being probable, probability, right? Sometimes it takes a long time before we can establish a causal relationship scientifically through scientific method. We might have to falsify 52 hypotheses before we even get the confidence to say that A causes B, for instance, right? But that's the goal of scientific inquiry, is to make judgments about what causes what. And that's why you propose different models of explanation, right? So, all right, so I'm going to stop doing the video. Thank you for listening, and there will be a separate homework review of the problems in 1.3. Thank you for your time.